Every time you flip a light switch or plug in your phone, you're plugging into the single largest machine on Earth. It's absolutely massive. But have you ever stopped to wonder who actually keeps that whole thing running? Well, today we're pulling back the curtain on the guardians of our modern electrical world, the power systems engineers.
And look, this couldn't be more urgent. The power grid we've all grown up with, it's in the middle of a massive, once-in-a-century revolution. Everything about how we generate and move electricity is being fundamentally rewritten right now.
So, what is this huge challenge that these engineers are facing? Well, it's not just one thing. It's a whole collection of massive, interconnected problems that they have to solve all at once.
Just to give you a sense of scale, think about it. We're talking about a system that stretches from gigantic power plants across thousands of miles of high-voltage lines all the way down to the individual outlets in your wall. Getting all of that to work in perfect harmony 24/7 is, well, it's a monumental feat of engineering.
And that monumental job is getting harder every single day. First, you've got the massive push to net zero. That means weaving in renewable energy, like wind and solar. But here's the tricky part. Unlike a big old power plant, the sun isn't always shining and the wind isn't always blowing. So you have to manage that unpredictability, all while keeping the grid stable, keeping everyone safe, and upgrading infrastructure that's, frankly, getting pretty old. It's a real pressure cooker.
So, that's the big question, right? How on earth do you manage a machine this vast and this complicated with all these new demands piling on? The answer, as you might guess, lies with the engineers and the incredible set of tools they have at their disposal.
So, let's peek inside their toolkit. And I'm not just talking about a wrench and a hard hat. We're talking about a powerful mix of sophisticated hardware, brilliant software, and just plain old deep-seated expertise.
First up, let's talk about the hardware, the physical stuff, because this is definitely not a job you can do just from behind a computer screen.
And this really shows you the two sides of that coin. On one hand, you have this incredibly complex, sophisticated technology, like circuit breakers, that protect entire sections of the grid. But on the other, you have the human element. Working with this kind of high-voltage gear is incredibly dangerous, so personal protective equipment isn't just a suggestion, it's an absolute lifeline. The stakes are just about as high as they get.
Of course, all that amazing hardware needs a brain. And in the 21st century, that brain is a whole suite of powerful, specialized software.
You see, you can't just guess how a change to the grid might affect things. You have to simulate it. Engineers use these insane software packages like PSSE and PSCAD to build digital twins of the entire power system and test every possible scenario. And as one engineer on Reddit put it, these aren't your everyday apps. They are incredibly complex platforms that let them model the physics of the grid in mind-boggling detail.
Okay, so you've got the hardware, you've got the software, but none of that matters without the human brain to put it all together. That's where the deep, foundational knowledge comes in.
And it really boils down to a few core skills. First, maintenance. You have to know the nuts and bolts of how to keep everything from transformers to giant battery systems in perfect working order. Then there's fault finding, which is basically being a detective for a country-sized electrical system. And finally, teamwork. No one does this alone. It's all about collaborating with huge teams to get these massive projects across the finish line.
All right, so we've laid out the problem, and we've looked at the tools. Now let's make it real. Let's zoom in on a specific role to see how this all comes together in the real world.
Let's talk about a grid compliance engineer. So imagine a company builds a brand new, massive wind farm. Well, you can't just plug it into the grid like it's a toaster. This engineer is the person who manages the entire incredibly complicated process of proving to the national grid operators that this new facility is safe, reliable, and won't mess anything up. They're the ultimate gatekeeper.
And a day in their life? It's a total juggling act. One minute, they're buried deep in super technical electrical designs. The next, they're on the phone negotiating with the national grid. Then they're briefing project managers, answering questions from investors, all while making sure this multi-million-dollar project stays safe, on schedule, and on budget. No pressure, right? So you can see how complex this job already is. But the field never, ever stands still. Just when you think things can't get any more complicated, a brand new, game-changing tool is showing up on the scene. And that tool is artificial intelligence.
We're talking specifically about large language models, or LLMs. Now that sounds super technical, but the core idea is actually pretty simple. Think of them as pattern-finding systems on steroids. They're built on a design that lets them understand not just words or numbers, but the relationships between them. This means they can learn incredibly complex patterns from just about anything.
Technical manuals, software code, even live data streaming in from sensors all over the grid.
So, how does this actually help an engineer on the ground? Well, the possibilities are kind of amazing. For fault diagnosis, an LLM could instantly analyze an error and compare it to every other error that's ever happened, suggesting the most likely cause in seconds. Or for knowledge management, it could act like an expert assistant that has memorized every technical manual ever written. It can even help with cybersecurity by spotting weird patterns in network logs, or help write the code for those complex simulations we talked about earlier.
Now, this is the most important part to understand. AI isn't here to replace these engineers. It's here to augment them. It's a tool that can do the heavy lifting of sifting through mountains of data, freeing up the human experts to do what they do best: solve problems, innovate, and make those final critical judgments. It's a force multiplier.
And that leaves us with a really exciting question to think about. If you give these incredibly smart engineers a tool this powerful, a tool that can see patterns no human ever could, what are the big, seemingly impossible problems that they're going to solve next? What does the future of our power grid even look like?